Okay, so welcome everyone. I am Chetan, and I have a couple of roles in Hitachi. I lead our AI center in globally in R&D, and also a lab which is focused specifically on industrial applications of AI in North America. And I've been Hitachi for quite some time now. And over the years, we have worked with a large number of industrial customers, and I'll try to share what I've learned over all these years with the audience here. Just a bit of a background for people who don't know. Hitachi is a giant sort of industrial conglomerate. We're in multiple verticals, industrial verticals like rail, energy, um, and then as well as some IT verticals. We have a pretty strong presence in terms of delivering solutions, building solutions. So I will try to bring both of these aspects together as we talk about what AI can do for manufacturing. So just to sort of, since Katie said it's a Monday morning, uh, let me sort of just start with this very simple slide. And I'll ask a rhetorical question because I guess everyone is muted, so I can't hear people's responses. But the question is, what is common to all of these? And over the years, I have sort of heard very many answers to this question, but few people have gotten it right. And the answer is that all of them contain motors, right? So we wouldn't have thought about it. It wouldn't have occurred to us that what's common to all of these very different devices or equipments or instruments is a motor. But motor is ubiquitous. And my or our thinking is that so will AI. So AI will be everywhere and we just won't notice it. It will become integrated into our products, into our everyday life. And that's why it's important for us to really understand what AI is at some point, at some level, and how can it help us impact us in our day-to-day job. So today, that would be around manufacturing. So I'll start by level setting and sort of giving a very brief idea about what AI is. And ML AI, I know recently, around a couple of years ago, when ChatGPT was first announced, people started noticing AI, but AI is a very old field. I think quite some time ago, I did my PhD in this space. And so for me, before AI became AI, we have been at it. So it's the one way to look at AI is that if you have a lot of data, and what you want to do is you want to build a model on that data to describe the data. So for example, on the left-hand side, I have these couple of several dots. Some are blue, some are green. And I want to build a model that is able to uh, discriminate between blue and the green dots, right? So can I draw a box, some sort of a shape, some sort of a box, I would say, in on the image on the left-hand side, so that the red and the green and the blue dots are separated. Okay. And on the right-hand side, you see what the model, what the box looks like. So if you follow this idea, then, and if you think from an analogy of manufacturing, so in some sense, your data is your raw material. The algorithms or the methods that create the model is like a manufacturing process. And what you get out of it is a widget. So in very many ways, what machine learning is doing, it's producing models. The other thing to notice is that when I made that box, there is one green dot that is within the box, right? So I was supposed to make a box that only captures blue points. And the reason that uh, the green dot is there is to sort of tell you that machine learning models are statistical in nature, and so they often make mistakes. And so as we think about AI and machine learning going forward, it is very important to understand its impact, but it's also important to appreciate how to use it because it is not a method that is completely usable out of the box. Okay. So this is machine learning AI traditionally as we have known it. Then 2 years ago, as I said, everyone sort of started talking about AI because of ChatGPT. So ChatGPT is considered an example of a subfield of AI called generative AI. Okay. And generative AI is type of AI that is used to create new content based on the existing models trained on either text, visual, audio. So that's why when you chat with the ChatGPT, it creates new text, so you can talk to it. And the way it does it, although it looks magical, it generates one word at a time. So you say, hello, how are you? So you say, I, and then am, then good. It is not going to generate I am good in one way, right? So it generates one token at a time. And so one specific class of these generative AI models are the language models, meaning they essentially generate language. And GPT-4 by OpenAI, Llama 2, Bard by Google are examples of LLMs or large language models. They are very, very large. They contains billions to trillions of parameters very often. And now we are looking at multimodality, meaning so initially they started off as being large language models, but now they're able to generate images and other modalities. Thus, text is one modality, images other modalities. That's why they're called multimodal. So the one big impact of this is that now these models are so large that if you go back to the previous figure where I said you need your own data, and then you need to train your model on that data, instead of that, these large models don't need to be trained on your specific data. So there are other methods of exploiting your own data with these large models. And from a manufacturing analogy, the impact of this is significant, right? So if you think about your manufacturing process, you're producing something. So earlier, going back to this slide, you had some raw material, and for the middle red box, it wasn't you needed some workers, some artisan to sort of play around with the raw material to get the final output. In some sense, with generative AI, it is moved to automation. So instead of you need a domain expert or a data scientist to take your own data and build a large model, then build a model and then get output of it, you can directly begin to use the model. So one way to think about it is in terms of the value and the scale of what it can do. You have made a transition from a skill-based production to much more of an automation-based production. So that's what generative AI is. And then what is industrial AI? So industrial AI is a way of thinking about AI in terms of its applications. So fundamental technology remains very much the same. Either you're building your own model or using generative models. Sorry, this is a updated slide. Anyways, so what industrial AI does, it applies AI to multiple fields in the industrial space. And so, for example, industrial AI for manufacturing, industrial AI for energy sector, industrial AI for rail. So AI has an application in all these fields. And when we think about industrial AI, we think of some systematic horizontals of applications, like maintenance and repair, operations optimizations, quality, supply chain management. So when you begin to apply AI to these particular horizontal functions that are common across multiple verticals, that's when you get industrial AI. So let's sort of take a step back and think about why AI has become so important, so popular. And part of it is because earlier a model used to be small because the data that we had was small. And on the plot in the left-hand side, I'm showing how data has sort of increased. So the very bottom is transactional data. So this is data in traditional databases, the transactional systems. And then you have the social data with the green line. So this is the data that was generated when Google and Facebook and all of that became very important. And as you can see, this amount of data is increasing exponentially, the sort of exponential scale on the left-hand side. And finally, you have machine data. So this is the data that's being produced by sensors or events and so on and so forth. And the amount of data is increasing exponentially. So the model size and how useful a model is often dependent on the size of data. So as a result, these models have become larger and much more robust. And in this sense, from Hitachi's viewpoint, we think of enterprise data, right? So if you think about how OpenAI's models are being trained, which came up with ChatGPT, or if you think about how Google's models are being trained, so they are often trained on publicly available data. And if you think about the whole data landscape, the publicly available data is just sort of tip of the iceberg. And around 80% of data is within the enterprise. And what we want to do, what we want to think about is how can we leverage this data to enable customers and Hitachi's own transformations. So the journey that we are sort of working on with our customers is something we're doing internally as well. So we're thinking how we can use our own enterprise data, whether it is data that's on the shop floor or whether that data is from our HR functions. How do we utilize that to make ourselves much more efficient and competitive in the longer term? I'll take a pause here. Katie, any questions till now? Please feel free to type your questions in the chat if you have any. And I will periodically stop and sort of try to answer these questions so that I don't sort of monotonically drone for the next 1 hour and all of you get bored out of your mind.
No questions yet, but participants feel free to use the Q&A box, or you can raise your hand and we can call on you.
Wonderful. All right. Okay, so now we initially talked about generative AI, we talked about traditional AI, and then I talked about industrial AI. So in this figure, on what I'm trying to say is how we use generative AI and industrial AI together to build new applications. So if you look on the left-hand side from a shop floor standpoint, you have a workforce, you have operations and assets, right? So typically we talk about 4 M's in manufacturing. So when you think about workforce, there is a lot of natural language communication data that is there. So there is also image data that you might capture of your workers working. So here, because this data is of the unstructured type, meaning it's a language or image data, there are very many generative AI applications possible. So you see the red bar. So red bar is generative AI, blue bar is sort of industrial AI. And as you start thinking about operations, this is your operations data. So manufacturing supply chain, you're optimizing your operations, your warehouse operations. And there is a mix of both generative AI and enterprise, so industrial AI. And finally, you should think about just your assets themselves. The natural language or image data becomes much lesser, and the sensor and event data become much more important. And as a result, sort of much more of industrial AI applications are possible. And what you do with this is you build different kinds of models, the foundation models, meaning these are large models that can solve problems specific to your industry. So we want to make these models reliable. We want to make them model multi-domain, multimodal, energy efficient. And for specific applications like supply chain, industrial copilots, organization transformations, inspections, and end-to-end solutions, end-to-end optimization of your operations. So as I said earlier in my introduction, we have been working in the space of industrial AI for a very long time. And what you see here are the problems that we have solved over all these years. So starting from maintenance and repair, operations optimization, quality assurance, and supply chain management. Each of these problems was brought to us by a customer, either internally or externally. And this makes me confident that for your industry, for your particular job type, there are problems that AI can solve and make it much more efficient. And in the next section, what we'll do is we'll go through examples of kind of problems that we have solved with industrial AI and manufacturing. So that is the customer use case section. There seems to be one Q&A. Katie? Yeah, okay. Do you want me to read it out loud? Okay. So there's a question from V. Are there direct applications for AI that you've applied to customers with substantial productivity that can be measurable? Yes. The answer is yes, V. And I'll talk through some of these use cases in the next section. Okay. All right. That's actually an excellent question. And that's the most relevant question in some sense, because you often hear people talking about AI, how AI is changing the world. And if you try to look underneath the covers, you often find there are not that many substantial use cases. And at Hitachi, we are very grounded in the reality, in the real world. And so we try to sort of solve real world problems. So let me start with maintenance. Right? So this is a problem that came to us from a Japanese OEM. So I can't share the customer name, but they use robots for manufacturing. And um, what they really wanted to do was find out if the robot is failing even before they failed. So the way to address the problem was to obtain the 3D vibration data from the robot. And then we built sort of a machine learning model that was able to predict um, whether equipment is going to fail or not by detecting anomalies. And there are multiple motions in for a robot, as you know. And for certain motions, we were able to predict with 100% accuracy that there is something wrong right now, and the machine needs to be fixed. This is another OEM from Japan again. And this time, the first one what we talked about was maintenance, whether something needs a maintenance or not. But very often we do maintenance and we don't know whether it is effective or not, right? So I have a very favorite story to tell here. When I first came to the country, I bought my first car, and it was recommended that you need to change an oil every 2,000 miles or so, or even 1,500 miles, right? So turned out it was a scam, right? So no one really needs to change their oil every 1,500 miles for any car, right? And so, but a lot of people believe that, and at least suddenly I believed it for a long time. And one way to sort of address such a problem is to see if a maintenance really makes an improvement to your equipment or not, right? So you take your equipment and you do maintenance and you look at the performance before and after. And if you're able to then see a statistical difference between the performance, then yes, the maintenance was effective. If not, then maybe it was not. And once you use this idea, then you can do all sorts of analysis. You can see whether a particular maintenance practice is useful or not, whether a particular vendor is useful or not, whether a certain worker is doing his or her job properly or not. So this has proved to be quite a useful application in terms of trying to reduce your maintenance cost, right? It's very akin to sort of people say in marketing, right? So I spend $100 in marketing, only 50% is useful. I just don't know which 50%. I think maintenance is like that as well. But with these sort of analysis, then you can sort of at least try to get an idea about which 50% is useful for your particular job. So those are two use cases in maintenance. And I'll share a story about a use case that's not from manufacturing, but has been extremely successful for us. So as you know, there is as you might know, one of the largest fleet companies in North America is a company called Penske. So you must have seen their big rigs on expressways. And so these Class 8 trucks are really very, very difficult to maintain. They're quite complicated. So what was happening is when these trucks come in for repair, technicians are trying to make the repair, face two challenges, right? So they often don't know how to diagnose it, and they're under time constraint to get the job done. So especially the newer technicians who are not as well trained, so they would essentially declare a repair done and send the vehicle back into the field. And most often, or very often, the vehicle would come back with some time. So that is called a repeated repair. So we were able to build a machine learning model that when a vehicle comes in, it correctly predicts or recommends the right repair action. Okay. So with that, the technician's diagnosis time really goes down. And this had a significant impact on their bottom line. And this is one of the examples that has been really revolutionary in terms of their day-to-day operations. So now their vehicles are in and out much quicker. There are much fewer cases of repeated repairs, and that's what sort of has been really very impactful for them. There are more. So I'll take a pause here, Katie, and see there are more questions. V has another question again. I have seen AI solutions which is being pushed by the bigger vendors that most enterprises using Salesforce, SAP, Oracle, etc. How can a mid-market companies kind of understand what are the core use cases where we can create our own AI solutions, and how do we go about that? So I think Nick should answer that. I think this is a very good question again. And my thinking on, I'll come to that towards the end, maybe when I sort of talk about how you should think about AI solutions. And so I will remember that question. There is one slide that explains how you should sort of think about this kind of a problem. So please keep the questions coming. Okay, so now we talk about manufacturing and repair. Let's talk about operations.
We do have one more question in the chat, Chen.
Oh, from Kiara. What are the key challenges that manufacturers typically face when implementing AI, and how can they be overcome in the early stage? Okay, so let me sort of answer that. I will sort of emphasize it again later. So I think very often the key challenges with when people are trying to implement their solutions is they don't know where to begin, right? So they're often lost in terms of, what is the data that they have, and given the data, what is the problem that they can solve. So I often think of it as a three-step process. So you first think of the business problem. So this is where the domain experts or people who run the operations are really instrumental, right? So you look up the domain. So you find, okay, these are some of my important business problems. Then you sit with someone who is sort of trained in machine learning, AI, someone like Hitachi, and they will say, okay, for this problem, this is how maybe we can formulate it. This is maybe how we can solve it. And then you get your IT team on board to see if there is data to address the specific problem. So if you have a business problem, a possible mathematical formulation for the problem, and the data to solve it, and you iterate through this, then that is the best way to get started. But as one of my friends says, the best way to get started really is to get started, right? So you just um, understand that maybe initially it will be slow progress. It is a learning curve. But as you gain more and more confidence, and we have seen this with very many of our customers, so they start small. And as we do more and more projects, they begin to understand the process. They begin to get a much better understanding of the limitations and strengths of AI. And then it becomes a very healthy sort of a relationship where we discuss mutually what is the next possible thing that you could do, which has the highest ROI, what is doable, and that sort of is, I think, the best way to get started. Hopefully I answered that question, and then I'll move forward. If it's not satisfactory, please type again and we can continue to sort of discuss that. So the next is around, so we talked about maintenance repair. Let's talk about operations now. So one of the use cases is around operators, right? So this is again one of the largest steel producers in the world. This was one of the funnest problems I've done in a long while. So this is a steel rolling mill. So what happens is you have to you have to get the steel to a very even thickness, because otherwise when you roll it, it telescopes. And if it telescopes, then your customers will not buy that. And so a worker sits and he has two joysticks in their hand and two pedals. And they use that to control the speed of the as the steel goes through, and then flip it and then send it back and flip it, send it back till it gets to the right length. And this is between hot rolling mill and cold rolling. And so what we did was, and this was a union shop, so we can't directly instrument a worker. But based simply on the operations data, we were able to characterize, based on sensor data coming from the operations, we were able to characterize each operator's skill. And then you're able to correlate the skill with the quality and say these are the good behaviors, operator behaviors, that can lead to better quality. And this has multiple use cases. You can sort of train workers, and this is the right way to do it. Or you can, if you're tracking the performance, then you can say, oh, the performance seems to be going down, because now you have a benchmark of what a good performance looks like. And then you can make recommendations on how to improve it. So this also has significant implications in terms of making your workforce much more productive. And this project, in fact, started out with GPS data. That's the most interesting part. So if someone had come to us and they wanted to understand driver profiles based on GPS data, right? So this is, again, you're not monitoring a driver. You're just looking at the GPS data, which is completely anonymized. And it turns out that all of us have a pretty unique driving signature, right? So the way you accelerate, the way you de-accelerate, the way you take a right turn, left turn, how do you move at a stop sign as opposed to a red light, right? So all of these things characterize us. And I think we're able to identify drivers up to more than 90% accuracy, just based on GPS data. To me, that was very alarming as well, right? Because it's a bit scary. But similarly, humans have a very sort of a signature way of doing any job. And if you can get that signature from the sensor data, then it can really be helpful. Next slide. So this is order delivery lead time prediction, right? So this is for a manufacturer that was doing make to order, right? So they have part of the assembly done, but the final assembly is done only once they receive an order. And once they receive an order, they need to reply with the accurate shipping date. And then you need to, based on the shipping dates and what the customer is asking for, you need to optimize the production lines. So we sort of solve this problem for a customer. So when the order comes in, what is the likely, given the existing orders and the existing backlog and inventory, what is the accurate shipping date? And then if we need to make any changes to the production process to meet a guideline or a deadline from a customer. So this was another problem that was very successful. This was for a US customer. And this was done in Australia. So this is for coal mining companies. So mining is quite similar to manufacturing in many ways, but for coal mining especially, once you mine the coal, it goes to something called CHPP, coal handling and processing plant. So there you separate coal into its grades. So then you can get the right mix and send it to a customer. So customer typically buys a mixture of grades depending on what they want to do with that coal, what the end use for the coal is. And in Australia, this is sort of very fascinating operation. This completely automated. These very long trains are filled with a particular with different sort of composition of coal, and they go from the CHPP all the way to the port. And we call it pit to port optimization, right? From open pit to the port, can you optimize the end-to-end process? So, but one important problem there was in the CHPP, there are multiple processes. And if a upstream process goes down, as you can imagine, the downstream processes get impacted. And so the idea was, can you predict that the upstream process is going to fail? And we were able to do that, and it resulted in at least 5% accuracy increase in the revenue, because now if you can avoid the upstream failure, the downstream failure doesn't happen, and the whole plant's productivity goes up. And so this was done for a pretty large mining company, coal mining company in Australia. Next slide.
We have a question in the chat
Okay.
around workforce.
How do you think AI is changing the skill requirements of the manufacturing workforce? So this is I think this is a very good question. So I think 2-3 years ago, I was somewhere in Kansas talking to one of Hitachi's manufacturing companies. And they said that the biggest challenge for them at that time was availability of workforce, right? So a lot of the younger people don't want to work on shop floors. Everyone wants to work on a computer. And I think AI can help ameliorate the concern around workforce, right? So you can do several things around workforce. So you can do some level of automation. You can increase the productivity of your existing workforce, and you can do much better training using AR, VR kind of applications, right? So we have done work on building training modules using VR for workers. So these are some of the things that you can sort of do in terms of improving the workforce productivity. And you can make also specific recommendations now on how a particular worker can improve his or her productivity by taking specific actions. So I think there's a significant potential of AI being a tool for worker productivity. And that's how often I think about it, about AI. AI is not at a stage where most things can be automated. AI is today primarily as a tool that can help us in our day-to-day jobs, right? For example, I use AI very often now to write emails. Writing emails is not my strength, but I have to do that as part of my job, and especially sort of emails that go to large group of people where, they're more formal emails. So when it comes to writing formal emails, I often turn to ChatGPT or some variant thereof. But yes, so I think we should think about again. I think this is tying to the previous question. You think about what are the biggest challenges facing your workers, and what part of it can then be addressed using AI. And I think there would be an answer to that. All right. So continuing with my example. So this is out of India. As you can see, Hitachi has a global R&D operation. That's why you see use cases around uh, from different parts of the world. We talked about just from Japan, North America, Australia, and this one is India. This is one of the largest aluminum manufacturers in India. And I've forgotten the exact process of smelting of aluminum now. So please, if I say something wrong, people who know aluminum smelting, please don't ding me for that. But the idea was that you get multiple pots, and every pot is labeled with grade A, B, S, C. And and the challenge for them was, and A is the highest quality, B is the second highest quality, C is the third highest quality. And the problem that they were facing is they wanted to improve the percentage of A in the mixture of A, B, and C. So what we were able to do there is look at the different sensor measurements and see what was leading to more B's and C's. And then you can then adjust for those parameters to get a larger number of A's compared to B or a C. Uh, the factory, I think, wasn't the largest factory. All the manufacturer was very large. This particular, I think, solution was done for one of their mid-size operations. And then this is dynamic dispatching. This is something we did just last year. And this is for a warehouse operation, wherein they had used iPhones. So depending on some tests that you do on the iPhone, either iPhone is recycled completely or it is sent for refurbishing. And this sort of is a continuous chain of moving belts. And the idea was, how could you improve the throughput of this handling system with dynamic and uncertain material requests? Because we don't know what is the distribution of iPhones that is coming in, right? In some sense, what properties they have. So we did two things here. So first, we built a pretty high fidelity simulation of the whole line. So meaning, where is the processing equipment and how fast is the belt moving? Where is the congestion point on the belt, where it the equipment either goes in one direction or the other. And then we optimized the certain parameters as the belt is moving around this operation. So it includes, right, at what speed it should move, where should it slow down, by how much, sorry, when it should slow down, by how much. So these were a couple of parameters that we tuned based on the simulation. And this is not traditional optimization problem, but something very deep in machine learning called reinforcement learning. So if you remember a few years ago, there was a lot of noise around first chess and then AlphaGo, right? So AlphaGo is considered a very tough game for humans. And the champion is something called AlphaZero, which is essentially a computer. And no human has been able to beat that. I think that was at least a few years ago. And that is the idea. So they used something called reinforcement learning, that you reinforce a good behavior of an algorithm. So when it does something, it results in a good output. You sort of say, you give more reward to it. It keeps doing that. And so that was the idea behind AlphaGo. And we're using very similar idea around this as well, right? So when you take a decision to slow down the conveyor belt or to speed up the conveyor belt, if it leads to a good outcome, then you give a reward to the model. And eventually the model learns to be highly efficient at making the right prediction, right recommendation on how you should move your moving belt. Okay, so there are no more Q&A. So we talked about maintenance repair. We talked about operations. Let me talk quickly about quality. So this is another automotive part manufacturer. This is in North America. This is part of Hitachi, and this is about how high pressure pumps and motors. And the idea is that so you're taking the manufacturing from assembly, you're assembling this high pressure pump and going from one stage to the last stage. And the testing is being done just before it is being shipped. And if there is a defect at that point, then all the work that has gone on till that point is wasted. So based on the smaller test that you were doing up to the final test, the idea was, could you then predict whether this particular assembly is going to be defective, going to fail the final test? Because if you can predict that it's going to fail the final test, then you can intervene early and save the work and material that has gone into that. Then this is another steel maker in Europe. I would think this was Turkey, not Europe, really. And the idea was, could you predict the quality of the steel that is going to come out depending on the sensor measurement? So earlier we had talked about a steel mill where we were profiling the worker. This time we are trying to see if you can actually predict the quality itself based on the sensor data. And this is around the shape measurement. Again, very similar, the thickness and the profile of the thickness for the coil. And then this one is something we did just a couple of years ago, was to look at welding and see if it is defective or not. There's certain kinds of defects. For example, there are spots here. These are called bubbles, I think. I forgot exactly what they are. Cracks, splatters, and porosity. And what was very interesting was the customer only had 30 odd images from the welding operations. And what we did was very interesting. We said, okay, if you want to look for a crack, for example, a crack looks very similar whether it's on the road, on a highways, for example, and if it is going to be on a on a welding. So we first learned a model for cracks on highways because there was a lot of publicly available data there. And then once we had this model for cracks, we then fine-tuned it for welding cracks. And the reason I sort of put in this example is because it tells you that even if you might think that you don't have a data for a particular problem, there are ways to sort of overcome that problem. So that's where machine learning experts can come in and they say, look, you might not have the data for this, but maybe we can use this other data to first train the model and then fine tune on your particular data. And then supply chain management. Again, so this is for a mid-sized construction company out of Japan. And we wanted to accurately forecast demand in North America. So demand forecasting, everyone understands, but this is multi-echelon supply chain. And so we were able to sort of use both external data and internal data to make demand forecasting. I'm trying to speed up a bit. And then we have built a very sort of a simulator that can simulate supply chain. And this is for one of the largest apparel companies in Japan. And once you can simulate a supply chain to the right fidelity, then you can do much better inventory plan, right? So then balancing inventory costs with customer order fulfillment rate. And we're able to reduce the customer's inventory cost by 1/3 while keeping the same level of fulfillment rate. So now let's look at generative. So what we looked at, which is sort of traditional, I call traditional use cases with AI and sort of with industrial AI. But last couple of years has seen, as I said earlier, a burst in the interest with generative AI. And how does that sort of work, right, with the industrial context? Because we are often looking at data sets that are small industrial context. And the publicly available models often work on language. They are trained on publicly available data. So there are sort of, one way to think about it is for your upstream processes like design or RFP response, we can build generative AI models, and we have done that, right? So if there's an RFP, how do you quickly sort of estimate the price of fulfilling the RFP? And if you want to create initial design, then that can be done with that upstream with generative AI. On the downstream customer support, I think all of you might have heard that people are trying to automate customer support with generative AI. And then in sort of for the core industrial AI operations, very often the thing that you're manufacturing might come with some OT software, right? So you can use AI for that as well. So Hitachi is working in all these different spaces. let me give you a very quick example of generative AI here. And so this is, suppose you have a service manual bot, and the idea is, can I now answer a Q&A over the service manual? Okay, so this can really help reduce the maintenance time if your shop, if something happens on your shop floor and you want to quickly repair it. And this is an openly publicly available manual from Hitachi Excavator. So I can ask a question: what should I do to prepare the HCM excavator for inspection? And it will give, and so not only does it give an answer based on your data, this is your manual, but our method also is tells you the right location where that information is, so that a human can ascertain for sure that that the information is correct. Remember, I said earlier, we are essentially dealing with statistical models, and they can make an error. So as we think about using AI in the industrial domain, we have to make our systems much more robust, much more reliable. And this sort of the idea of grounding, meaning not only giving the answer, for example, here it says, please check page 18, right? So for 128, sorry. So you're not only able to give the answer, but then the user is able to ascertain that the answer is correct when you point the right location to it. So let me give you sort of this is the first thing that we did. Now, the second thing that we did is what we're doing is building domain-specific models. So what this really means is, if you think about ChatGPT, it's a very, very large model, right? It's a very large language model, and you can ask it all kinds of things, right? You can asking about like what's this, who is the last president, who is going to be the next president, what happened here, what happened there. But for your use case, you really don't need any of that information. You want your model to be trained on your data, on your sort of specific to you. So why would you want to pay for a very large model? So what we are trying to do in Hitachi is build models specifically for you. So these are called domain-specific models or domain-specific large language models. And so they answer the question much better when you ask a question as opposed to a general purpose large language model. And this is an example here, right? So if you ask, this owner has a complaint of an odor when the air conditioning is on and is suspecting a problem in the evaporator core, what could be the potential reason? So if you ask this question to ChatGPT, you can try the experiment. Maybe things have improved. This was a year or so ago. It gives you all these 5 reasons where the right answer is there, but it's hidden. It's at number 5. But if you use a domain-specific model, it correctly gives just the right answer. It doesn't sort of create superfluous information. So when you think about industrial use cases, this is what you need. So you need an answer that is correct, that is precise. And so let me give you an example of an application that we have built, or software that we are building. And this has been now deployed in a couple of places. The idea is that we do maintenance, but very often there is no systematic way of figuring out what is the right repair to do. And so one way to do that is to have a diagnostic tree, right? So you might have seen diagnostic trees in your sort of day-to-day work, but very often they are missing. So we have built a software that takes a manual and builds a diagnostic tree. So on the right-hand side, you see a troubleshooting tree or diagnostic tree. And then you can choose which components you want to focus on. And so based on the manual on the left-hand side, we are able to build this diagnostic tree. It is going to choose the components, and then you have this diagnostic. So what is a component? Let me just. It's an actual application, it takes time. Okay, there you go. So now you have a troubleshooting tree. So based on the trouble that you have, sorry. So it based on the component. So based on the component, the fault, it will tell you the fault, the cause, and the action. And then you have the diagnostic tree, and then you can ask a specific question of the diagnostic tree, and it will help you answer the question and tell you where the answer is. So for example, the troubleshooting tree bot will tell you the alternate bolt is slipping or the engine is overheating. So in this way, you can begin to use generative AI specifically for your own applications. Then another application, generative AI, is for supply chain disruption prediction. So in the previous example here, we looked at your own data, how we could build a fault tree over it, and then how you can navigate the fault tree to quickly sort of pinpoint your problem and fix it and repair it. In this case, you're looking at external data to see, given your supply chain, what external event can impact your supply chain. This is very much a work in progress, but it has become sufficiently mature that we plan to sort of use it or test it out with one of our partners and customers. So what we looked at now was generative AI use cases for the industrial world. And now I'm sort of going to answer V's question earlier. He asked earlier. So if you think about any industry, this is whether it's manufacturing or something else, the way I think about it is there are sort of two kinds of operations. One is the core operation, right? So you're manufacturing, your core operation is to manufacture, maintain your supply chain, optimize your supply chain, maintain your equipment, get the most productivity out of your manufacturing workers. So this is your core, this is your IP. So this is where you often need to build your own models. And if you don't have the sort of the skill set within the organization to do that, then you partner with someone like Hitachi to build those models. That is number two. Number one is your support processes, right? So for example, HR, finance, legal. So for many of these applications, the vendors themselves might come up with an AI model that you can use out of the box. They're not always sufficient. So I think the right thing to do is see if they meet your quality and your quality expectations and cost expectations. If they don't, then maybe you do need to partner with someone. So, but at least for these sort of common enterprise operations, I believe vendor can be a good starting point. An existing vendor like SAP or Oracle can be a good starting point. But something that is very core to your organization, like the horizontals we talked about, maintenance, operations, quality, supply chain. For these, you should try and sort of build your own IP that differentiates you, that discriminates you from your competitor. So that's number two. Number three and four might not be as relevant to the audience here, but for at least for us, we are interested in building new solutions and services for our customers and partners. And then number four could be applicable to you as well, wherein if you are making more intelligent products, thinking about how AI can be used to enhance the feature set. So for example, Hitachi makes storage devices. So we have made AI as a product configuration. It can help you figure out what is the right configuration of storage that you need to meet your needs. So this is sort of this matrix, this 2x2 matrix helps me at least think systematically about how I can use AI for my operations. And if I look at the enterprise and I look at the current state of where AI is, and yes, this is more for generative AI. So a lot of people are beginning to use bot and assistants for everyday tasks. So for example, I said I use it for my email writing every now and then. And if I have to create a document, I might use Gen AI. So that is at the very bottom. The next thing people are trying to use is for knowledge management. And so these two are quite popular use cases right now. And in process transformation, which is where the most value is, right? So can I transform my processes with AI? There are at least some areas where we are successful, especially around software engineering. But number four, where AI becomes smart enough to coordinate across multiple business value chains, that is still something we are not there as an industry. So I think there are some questions that I'll answer before I conclude. Well, this is a long question from Alan. But before that, Anonymous asks, what resources or strategies should manufacturers consider when building an effective proof of concept for an AI integration? So I think in terms of resources or strategies, I think the answer I think is you should start with what is your pressing business problem. And that should be the strategy, and then partner with someone who has experience in the space to do a concept of AI, of POC. So first try it out in an offline fashion. If it works, then integrate with your workforce, with your workflows. That would be the right strategy. Then Alan's question is, I appreciate your comments on the content of today's presentation. Thank you, Alan. There has been a lot of reference to success, failures, analysis, training, and operations to better plan, predict for desired results. All available, all valuable, but as small aerospace defense manufacturing company around in sales, fabric, so Alan, I think your question is spot on. My recommendation is to talk to Nick or myself, and at least we can help you get started on this. And I think especially in around requests for quotations and preparing proposals, generative AI can be very useful. And for the other things around productivity, quality, and reducing lead time, the traditional industrial AI use cases that we talked about can be quite useful. So what we have done is we have built these sort of reusable solution cores. So they're not solutions that are ready out of the box, but they are the sort of bare bones pipeline. And what we do is we, given a new customer, new problem, we fine tune it for that particular challenge. So that would reduce your cost of implementation and reduce the time it takes to build a solution. So those are the two things I would say. Then V says, Chetan gave you provide contact information. I think towards the end we will do that. Is that correct, Nick?
Correct, yes.
Okay. And let's go to the next question. One more anonymous question. Can we go down all the way? Scroll down. How realistic is to see ROI during your first implementation? So the answer to the anonymous is not to toot our own horn, but if you work with the right partner, then I think you can expect to see a realistic ROI. If you keep your expectations realistic, then you will see a realistic ROI. And I think it is very beneficial to start small and build on it with your own experience. And as a technology is quite mature now, but also I think within your organization, the change management and how you adopt. So I think starting small and then growing from there, I think that could be the right strategy for very many, depending on how large the operations are. But I think that's a very good question and a good idea. And then the last question, let's go scroll down. Katie, can you scroll down? Oh, I can scroll myself. Sorry. Does Hitachi AI have sessions on finance and core supply chain optimization across multiple functional areas? So we can set up a separate session on both finance and core supply chain for AI. So these are areas that we have a lot of experience in as well. So let's set up some time. How do you for AI evolving in the manufacturing sector over the next decade? So this is a very good question from Anonymous. So I think one way you will see is that the field worker, the tool set available to field worker will get enhanced a lot. So we'll see, so that will be one change that we will see. We'll also see a lot of optimized decision making. We often talk about a zero factory, meaning zero defects, zero energy wastage. And so end-to-end optimization of manufacturing where you're able to really optimize for energy consumption, reduce waste is where you will see. So on one hand, you will empower the workers to do their job much better. On the other hand, you will optimize your systems, your maintenance systems, your supply chain systems to really become much more efficient. Do you have concerns about AI to hackers using? Yes. So both. So I talked to sort of people who are concerned with this, and so one of the concerns definitely is that our physical systems are being attacked. Our power grid is being attacked every day. Our water system is being attacked every day. And this is, so AI can both be used as a tool to create new attacks. At the same time, it can be used to prevent new attacks as well. So AI in this sense becomes a double-edged sword. Since I have just a couple of minutes, I'll try to conclude now. I think there are no more questions. We covered all the questions. Right, so let me do this. So in terms of conclusion, back to my favorite slide. This is, I think, might answer some of the questions as well. So what can these motors teach us about AI? The idea is if you think about each of them, each motor is of a different size, different form factor. And that's how you need to think about your AI solutions as well. So ChatGPT will not do everything for you. It might only do a few things for you. So you need to really think about what your business problem is and what is the right AI size for that. What is the AI solution for that? And ultimately, in the end, humans, we believe in human-centric AI, and we want to bring OT, IT, and AI together to empower our human workforce and make the necessary changes in our sort of day-to-day work. So with that, I'll conclude.